20 labs in the U.S. Department of Energy's lab system. We are the only laboratory in the system that focuses specifically on renewable energy and energy efficiency technologies. Our mission is to work to increase the understanding of renewable energy resources and how to convert them to electricity and fuels for homes, commercial buildings, and vehicles. NREL's research focuses on basic sciences, biomass, building technology, geothermal energy, solar-generated electricity, wind energy, as well as advanced vehicles and systems and fuels. NREL Center for Transportation Technologies and Systems works to develop advanced vehicle and fuel technologies. I'm going to talk today specifically about our bus testing and analysis activities. We test and evaluate advanced technology vehicles for DOE's Advanced Vehicle Testing Activities, which is part of the Department of Energy's Vehicle Technologies program. Our engineers use the latest hardware, software, and analysis techniques to capture, process, and analyze data from in-service vehicles. We evaluate technology for impacts on fuel economy, vehicle performance, emissions, costs, and market readiness of the technology. Examples of some of the evaluations we performed over the years. We worked with King County Metro Transit Authority in Seattle, Washington, to evaluate 60-foot articulated buses which were equipped with GM Allison electric hybrid transmissions. That vehicle price was $645,000 compared to $445,000 for an equivalent diesel bus. The energy storage technology used in that bus is a nickel metal hydride battery pack. We noticed significant fuel economy improvements in the bus, up to 50% depending on the specific drive cycles that the vehicles were used in. Maintenance costs also were fairly comparable to the conventional diesel bus, and in some cases were actually slightly lower, primarily due to decreased brake wear. We also worked with Long Beach, California Transit Company to evaluate 40-foot buses, which had a ISE series gasoline engine hybrid system in it. That vehicle price was $462,000 for the hybrid vehicle versus $268,000 for a comparable diesel engine vehicle. Energy storage system in this particular bus is ultracapacitors. There we had an in-use fuel economy improvement which was actually a little bit worse when compared to the diesel buses on an energy equivalency basis. Maintenance costs, however, were significantly less, and this is again perhaps due primarily to brake wear. We've also worked with New York City Transit, evaluating the BAE series diesel hybrid vehicles versus both conventional diesel and CNG fueled buses. Those vehicle prices were $285,000 versus $290,000 for the diesel and $313,000 for the CNG. The battery pack technology was lead acid. Again, fairly significant fuel economy improvements on an energy equivalency basis, and maintenance costs were somewhat improved by about 22%. Conclusion there is hybrid transit vehicles, more expensive to procure, had somewhat higher fuel economy, lower fuel costs, better emissions, and maintenance costs were either lower or about the same. And most of these buses that we evaluated were fairly early production models, so there's probably significantly more improvements yet to come on the reliability side of things. Technology focus at the Center of Transportation Technology and Systems at NREL is not just on vehicle studies. but we also have energy storage activities. I like to say that there are only 3 problems with getting electric-powered vehicles into the marketplace: battery size, battery weight, and battery cost. And we're working with battery manufacturers to help address those problems. We're also working with companies that do power electronics, and there we're working on advanced thermal management techniques, and we're also working on technologies to reduce the vehicle loads on the auxiliary vehicle loads on vehicles, things like heating and cooling. Briefly, where we think there's opportunities for a national lab to collaborate with the Chinese organization includes areas like the Denver-Chongqing Eco Partnership on implementing electric and plug-in hybrid vehicles. And together with the city of Denver, my laboratory expects to receive some vehicles from an auto manufacturer in Chongqing, and we will be testing them at our laboratory. We also think there's opportunity to collaborate on advanced sprays for combustion of biofuels. We could certainly be sharing testing and evaluation methods for EVs, plug-in hybrid vehicles, and hybrid electric vehicles. We could provide software modeling and simulation training, training engineers from China's Automotive Technology and Research Center on the Department of Energy's PSAT and GREET software. We could jointly evaluate policy mechanisms for creating market pull for electric drive vehicles. We could certainly be testing prototype EV and PHEV battery packs using the DOE's laboratory testing resources and procedures. And certainly our countries could share best practices and to increase consumer demand through outreach, education, effective policies, and incentives. Thank you.